Welcome to this video on composites. This video is brought to you by Mayura Sontake. We begin by examining the raw sheet molding compound, or SMC, microstructure before heating. This uncured thermoset composite contains a mix of polyester resin, styrene, glass fibers, filler, catalyst, thickening agent, mold release additives, and air pockets. Next, we introduce temperature to the system. Heat penetrates the material from the mold surfaces, activating the molecules. The outer layers heat first, and the core heats gradually, creating a thermal gradient. Mold temperatures typically range from 140 to 160 degrees Celsius. The heat causes the resin to soften, and its viscosity reduces. Polymer chains gain mobility, and intermolecular spacing increases. This exponential drop in viscosity allows the material to begin flowing, leading to better fiber wetting. Catalyst activation begins with the decomposition of the peroxide. The peroxide absorbs heat, causing the OO bond to break, which generates highly reactive free radicals. This initiates the free radical reaction. Polymerization begins as the free radicals attack the double bonds. Styrene reacts with the polyester chains, leading to chain propagation. This is an exothermic reaction, where heat is released and the reaction rate increases with temperature. The balance between flow and reaction, or cure, is critical. If the temperature rises too fast, it can cause early gelation, which increases viscosity prematurely. This can freeze the flow front, leading to incomplete filling, voids, and weak zones. The gelation stage marks the transition to an elastic network. Molecular chains connect, and an infinite network begins to form as the material changes from a liquid to a gel. Mobility dramatically reduces once the gel point is reached. High-density cross-linking accelerates the cure. Cross-link density increases rapidly, forming a three-dimensional thermoset network. Styrene bridges create strong links. A higher temperature leads to a faster cure, but too high a temperature risks degradation. Maintaining an optimal cure window is critical. Strong adhesion at the glass fiber interface is essential for a strong composite. The resin must wet the fiber completely, and chemical bonding must develop at the interface. This strong adhesion enables load transfer. Poor cure results in a weak interface. The final thermoset structure is fully cured and stabilized. It features a dense cross-linked network with chains locked in place, resulting in high stiffness and strength. This structure provides thermal and dimensional stability, as well as excellent chemical resistance. Temperature directly controls the final composite performance. Low temperature leads to incomplete cure, weak properties, and poor chemical resistance. Optimal temperature results in high strength and the best performance. Excessive temperature causes thermal degradation, burning, and defects like cracks. The cure cycle overview shows the temperature, cure, and pressure profile. It includes controlled heating for proper flow, a cure cycle for optimal cross-linking, pressure to maintain contact and reduce voids, and controlled cooling for dimensional stability. This summary shows how temperature affects the chemistry and reaction rate. Below 80 degrees Celsius, the reaction is very slow. Between 120 and 160 degrees Celsius, the catalyst is active and polymerization begins moderately. Above 190 degrees Celsius, there is a risk of degradation and uncontrolled reaction. The molecular journey transforms the raw SMC through flow and fill under heat and pressure into a cross-linked network. This thermoset formation results in a strong, finished part. The final result is a product engineered at the molecular level. SMC compression molding uses temperature to engineer the molecular architecture, resulting in a lightweight, high-strength, durable, and high-performance material with dimensional stability and corrosion resistance. Includes the video on how temperature engineers the molecular architecture in SMC compression molding. Thank you for watching.